Welcome to the dynamic world of finance where every second counts and decisions are driven by a complex model. Today, we are once again dive into the fascinating world of forwards and futures contract. Especially, we are going to explore the magic behind their valuation, and that is the cost of carry model. We all know that a forward or futures contract will enable us to buy or sell an underlying asset in future. Let us take a buyer's perspective. Suppose this is our Mr. A and he wants to purchase 100 shares of a company now. To do this, he should have required amount of money with him. And if he has, then he can go and buy the shares. Suppose if he doesn't have requisite amount of money, then how can he buy the same? It's a big question mark, right? The only option available to him is borrowing. He has to borrow the rupee equivalent of share price from a financial institution, from a bank, or from a lender. Since he is using borrowed funds, on that he has to pay interest for a specified period of time. If asset he wants to purchase is a non-financial asset, means to say commodities like gold, then he also needs to incur storage cost in plenty. All these costs which we discussed now is the cost associated with his decision of holding the asset or carrying the asset now. Hence, it is called as cost of carry. This is the very foundation of valuation of forwards and futures. Now let me give you another perspective. In our story, we said Mr. A doesn't have sufficient money and hence he decided to go for borrowing. Now if he is going for borrowing, he needs to pay interest. The lender may charge him either simple interest or compound interest. If I have to ask you a question, which is better from the point of view of lender? The simple interest or compound interest? You will definitely say the simple interest is not better and hence he has to go for compound interest. If compounding, which is the best frequency of compounding from lender's perspective, he can charge annual compounding rate, then in that case, the equation will be A is equal to P into 1 plus R to the power T. So where P is your borrowed amount, R is the rate of interest charged by the lender, T is the time period which is 1 year annual compounding. So this will give you the amount to be given including interest to the lender. Now if we go further, if let us assume the lender is charging semi-annual compounding rate of interest, then in that case the borrower has to pay, that is Mr. A has to pay interest twice. In that case R will be divided by 2 and therefore our equation will be P into 1 plus R divided by 2 to the power 2t because he has to pay interest twice in that year because it was semi-annual compounding. Likewise, if we go further, if he is charging quarterly rate of compounding interest, then in that case it will be R divided by 4 and 4 times he has to pay interest and therefore it is 4t. And similarly, if we go further, monthly compounding, then it will be R divided by 12 into 12t to the power 12t. And likewise, if we go further from monthly to weekly, then it will be divided by 52 to the power 52t. And again, if we go further, it will be daily compounding rate of interest. Then in that case, R divided by 365 divided into to the power 365t. Now imagine if in case he is charging hourly rate of interest compounding, or if he is charging minutely compounding rate of interest, or if the lender wants to go to the fullest extreme, he can also charge secondly compounding rate of interest. Now, if you are supposed to do that calculation of secondly compounding rate of interest, you can really imagine the difficulty you need to face, right? So in this difficult situation, we can rely on a friend in mathematics, which is called as exponential value. So exponential values takes care of this difficult situation of finding the compounding rate of interest when the rate of interest compounds secondly. So this is the value, exponential value, which we usually incorporate in the valuation of futures and forwards. Now, if we are valuing the forwards contracts or futures contract, wherein we are assuming annual compounding rate of interest, then the equation would be F naught, which is value of forward today, is equal to spot price, because that is the amount which we are going to borrow now, into 1 plus r to the power t. So, but as discussed earlier, we said continuously compounding rate of interest or secondly compounding rate of interest is best from the lender's perspective, and hence we bring this continuously compounding rate of interest in the form of exponential value into our model, and this model will be our base model, and that base model is F naught is equal to S naught, underlying asset price now, into e to the power RT, exponential value to the power RT. So this is the model which we are going to use for the valuation of forwards and futures contract.